Hello everyone and welcome to the first technical webinar of 2022 in the EUROCONTROL Stakeholder Forum series. Today I'm happy that you've joined me together with our panelists to discuss, triggered by the 5G and radio altimeter debate that is going on currently, whether aviation is making good use of the scarce resource radio spectrum and what we need to do to protect the spectrum from harmful interference in both ways. So that's towards aviation and towards other sectors as well. And that's why we have a nice panel lineup today of representatives from the aerospace industry and the telecom industry and of course the spectrum world. And so these are Claude Pichavon from Airbus, Nikolai Vassiliev from ITU, the International Telecommunications Union, and Richard Womersley from LS Telecom. Together we will discuss what we can do to try and make aviation's spectrum fit for the future and its use fit for the future while dealing with the ever more crowded and increasing spectrum use overall. There is a Q&A function in this webinar, so please, if you have a question, submit it to the Q&A. And then if you have any specific technical issues or questions, you can put that into the chat. But for questions that are to be asked to the panelists, please put that into the Q&A. So we start first with the telecom side. And so Richard Womersley, we've worked together on spectrum studies before, and he is managing director at LS Telecom UK. And so I invite you, Richard, to share your first thoughts and slides, please.
Would help if I'm muted. Thank you very much, Gary, and thank you for the invitation to speak here today. I just wanted to say, maybe some of you don't know who LS Telecom are, so I just briefly wanted to share that with you, because I think it helps understand where I'm coming from in this debate. LS Telecom is a company, we're an independent company, we're not affiliated with any telecoms providers, and we work with regulators, we work with some international bodies like the European Space Agency, the European Commission, some industry verticals in transport, oil and gas, public safety, and telecommunications operators. So we understand the telecommunications sphere, but we don't represent any particular organization. And I just wanted to make that clear before we started. So we always hear this term exponential growth in demand, and of course it's not exponential, it's an S-curve. But anyway, the two look very similar when you're at the bottom end of the curve. There is an increasing demand for spectrum. It's driven by things like digitization, new technologies that require wireless connectivity, and of course, we can't deny the fact that there's growing demand for mobile and fixed data for consumers and other users. The question is, will that demand ever finish growing? And LS published a study, and based on the values in that study, we estimate that by about 2030, mid-2030s data demand will have slowed, and it will have reached about 30 times today's level. So there's still a long way to go, but it's not an infinite sum. And that demand is changing the way that we use the spectrum. And a number of sectors, the satellite sector, the broadcasting sector, the defense sector, to name just a few, have all given up spectrum for other people. They've shared their spectrum, or indeed, in some cases, they've been they've had to relinquish the use of their spectrum for other purposes. And of course, when you have demand, the easiest way of dealing with that demand is always to use more spectrum, but there are other methods that we shouldn't forget. You can also enhance capacity by putting in more infrastructure. If we're talking about mobile networks, that's more cell sites. If we're talking about satellites, it's more satellites in the sky. Also, we can use more spectrally efficient technology. And we've seen that happen in a number of industries. Terrestrial broadcasting has gone from 1 television channel per frequency to 8 or 10 high definition ones per frequency by using more spectrally efficient technology. Now, coming back to that mobile question, in the last World Radio Communication Conference, another 13 gigahertz worth of mobile spectrum was identified for 5G use. That's nearly 10 times the amount that was already available. So it's a very significant amount. And that additional spectrum is all what you might term millimeter wave. It's very high frequency. And that means it's only really useful in very, very dense hotspots. There's still a need for additional spectrum to provide coverage in cities, in suburban areas and rural areas. And of course, the aeronautical L-band, which is immediately adjacent to the 900 megahertz mobile band at one end, and almost adjacent to the 1.5 gigahertz mobile band at the other. It sits in that hotspot, sweet spot, and it would be fantastic for coverage and capacity for those mobile operators. And of course, when we look at that spectrum from the ground, we see very little, and we wonder, well, is it actually being used? The other thing that we see when we look from the outside in to the aeronautical industry is that there seem to be an awful lot of systems which fundamentally do the same thing. There's multiple different kinds of radars, including the primary radars, the secondary radars. And of course, from a telecoms perspective, the difference between cooperative and non-cooperative surveillance is possibly something that just goes over the head. You've got your non-directional beacons, you've got your VORs, all sorts of bands used for communication. You've got your radar altimeters, which I'm sure will crop up again today, but you've also got glide path, which you can use during an approach. You've got DME, which can help locate position, and GNSS. So there seems to be this multiplicity of systems that all do the same thing. And that's a confusion as well. Why do you need so many? Now, a lot of those technologies haven't changed significantly for the last 50 years or more. The receiver performance is based on technology of the 1960s. Spectrum efficiency isn't necessarily great. The methods of communication are quite outdated in some cases. And there doesn't appear from the outside to be a great push to do anything about it and make it more spectrally efficient. And there's always this argument that, well, aircraft replacement cycles are 20 years plus, and therefore our technology has to be workable for a very long period of time. And I think one other thing that's often heard when talking about aviation spectrum is the safety of life argument. You know, if you share spectrum or we give spectrum away or there's interference, aircraft will crash on takeoff or landing or somewhere in the air. And that comes over as a kind of willingness or lack of willingness to cooperate. Now, spectrum sharing is nothing new. The radio spectrum has been shared since the very early days of usage. But now we're at a situation where really there isn't any more of the good stuff, and we have to find better ways of sharing. And although the principles have been around for a long time, I think it's only now we're beginning to see real stretch in that ability to share. Now, this incidentally doesn't mean that I'm saying that aeronautical spectrum has to be shared with mobile networks. It could be there's something else that maybe aeronautical could share with that releases spectrum somewhere different, that then enables other services. Now, don't forget, the mobile industry doesn't stand still. It's not like they're just sitting on what they do. They change. They refarm spectrum. They move from 2G to 3G in the same band. We're seeing this now across Europe in 3G terms. The networks were switched on 20 years ago, and they're in the process of being sunsetted or switched off. That spectrum will be reused. So we see this technology development, and we've seen it in terrestrial broadcasting. We've seen it in PMR, we've seen it in fixed links, and we can even see it in satellites, where the same spectrum is now being used for low Earth orbit, as well as geostationary satellites. Now, LS Telecom some time ago, and Gary alluded to this, we did some work with EUROCONTROL to try and understand the spectrum efficiency of aeronautical systems. Some headline numbers, they're not really headlines, but just examples. The DME network could give the same level of performance with about half the existing number of sites. SSR, if you measure it in bits per second per hertz, is about 3% efficient with the use of spectrum. Compare that with LTE, which is on the same measure, at least 50% efficient. And some of this is down to historic planning rules like coupling of VOR and DME. Some of it's down to site placement. Putting sites at airports isn't necessarily the best place for them if you're trying to provide wide area coverage. We also looked at what you could do with 5G. Could you design something that supported aeronautical needs? And we managed to, using the standard 5G technology, come up with a network that would deliver up to 100 megabits per second per cell in an ideal condition, the usual party line, voice and data facilities that are needed, navigation accuracy of 100 meters horizontal and 30 meters vertical for 80% of the time, and surveillance as per navigation. All that was achieved with no more ground stations than the current DME network, and in only 20 megahertz of spectrum. So when we look at what's needed for aeronautical purposes, we begin to question why there is so much spectrum. So just to summarize, I think the aeronautical industry needs to better demonstrate why it is using spectrum efficiently. Be open about the facts and figures. What is it that you're doing? Why is it using so much spectrum? Why are you claiming it's busy? Consider intelligent ways of sharing, not necessarily with mobile, but maybe there are other users. I think in the UK now it's shared with program making. Examine options to upgrade technology more quickly. And also, and this comes back to the question of the radio altimeters, design systems to operate in today's radio environment, today's radio hot environment, RF hot environment. I think I've slightly gone over time, but only just, Gary, so hopefully that's okay. Thank you once again for the opportunity to speak, and I pass the chair back to you.
Yeah, thank you for that, Richard. It's excellent to get these perspectives and to hear about how we're being perceived. And so now we hand over to Claude Bichavon. He's executive expert for communication, navigation, and surveillance systems at Airbus. And so maybe he'll be able to address some of Richard's questions and also enlighten us more about what the Airbus vision is of how spectrum use will evolve on the aircraft in the future.
Okay, thank you, Gary. So hello, everyone. Next slide, please. So here you probably recognize one of the figure with the antenna location, which is an example for the A350 aircraft. So as you can see, we have a lot of what we call external antennas for communication, for navigation, for surveillance. Some of them are for passenger, some of them are for operation, for flight decks. But we have, I will say, common words which are coming regularly when we are speaking about what we call communication, navigation, surveillance for air transport. Here as Airbus, I will focus mainly on air transport. I will not touch about helicopters, neither satellite. And so I will focus on air transport and associated CNS systems. So we have safety, reliability, dispatch, cybersecurity, priority, availability, interoperability. We need to operate worldwide. We need to be compliant with regulatory words. And so this is what it is our language today in safety aviation. So for sure, it's sometimes difficult to understand with our colleagues from telecom operators when we are making application of those words. Next slide, please. Here you have, I will say, a focus on what it is aircraft communication domains. So we have, I will say, three main domains. Next, please. So you have the cockpit domain, which is composed mainly for cockpit operation, where we have communication, surveillance, and navigation. And this is what we call the safety and the protected domain. Next. Then we have the operation domains. Here we are looking for operations which are using, I will say, technology like Wi-Fi, cellular gate link. We are using also SATCOM. And so we are also using this kind of operation for administrative airlines communication. Next. And finally, the end customer after the airline, for sure, which is a passenger, where we need to provide him with communication means in order that he is able to communicate with the ground. And so for that, we are using systems like SATCOM, air-to-ground, and SATCOM broadband in order to get broadcast TV or information from the TV programs. Next, please. So here you have the three main domains, com, nav, and serve. So for sure, for communication, as explained, you have various type of communication. You have short-range type communication like VHF. You have long-range type like SATCOM or HF systems. And all those systems are always duplicated in order to, I will say, be compliant with airworthiness directives and to provide redundancy and safety of life demonstration. We have the same for surveillance, where we have, for example, the weather radar or the anti-collision system, where we need to ensure what is the environment traffic around the aircraft. And finally, we have the navigation system. We have the radio nav aids, the classical and old radio navigation system in place since the Second World War, like VOR, Marker, DME, IDF, and the most recent one based on SATCOM technology like GNSS, and also other systems which are coming. So these are the main topics. And for them, for example, we have a radio altimeter, which is a standalone system, which do not rely on any ground infrastructure, but need to work in order to assess and to perform the aircraft landing. Next, please. In terms of operation, this is also something which is very demanding. Among the cockpit communication, navigation, and surveillance systems, we need to provide the airline with operation and maintenance needs, and that during all flight phases. So for sure, for maintenance application, you need to, I will say, monitor your engine in order to, I will say, improve the performance even during the flight. You have the airlines ops application in order to be connected to the EFB with the weather, charts, and so on. Cabin crew application in order to, I will say, be able to manage galley content, so passenger needs, and also the cargo crew application in order to fulfill the cargo as the needs regarding the operation of the airline. Next, please. Last but not the least, we have new needs in order to fulfill passenger needs. We need to provide them with social media, sports, news, streaming, video on demand. And so the main idea behind that is also to allow the passenger to board his own device with connectionless. So nothing to do when you board on the aircraft, you are still able to use your portable in order to use or Wi-Fi or 4G or 5G. And this is for sure requesting more bandwidth and more connection with the ground. Next, please. Here, this is a view of an industrial like Airbus, where we try to make easier the installation and the rationalization of radio systems. For sure, we have recent technical evolution like software-defined radios, SDR, which will allow to optimize and rational aircraft installation. So for us, we consider that this is a good timing to lower what we call swap, size, weight, and power, even the cost for the CNS radio systems. So this will also to contribute to what we call the sustainability, because if you reduce weight, power consumption, you will have less fuel consumption and less noise, less drag. This also will help us in order to provide an easy installation in order to cope with the ramp up, in order to manufacture easily the aircraft and to answer to the demand from airlines. Next, please. This is the vision we have currently within the industry, and it is shared with various OEM and suppliers, where we try to go from, I will say, a distributed architecture to an integrated architecture. The idea is to try to avoid the way we are working today, one system, one box, one antenna. Here we are looking to make better integration through software-defined radios, through new networks for digital interconnection through optical fiber or Ethernet cables, in order to, I will say, optimize the efficiency and the installation of the aircraft, but also to be able to make combination Why not by spectrum allocation for the L-band frequency, for the C-band frequency, or for the lower frequency? So this is a trend today, and we are pushing to go this direction in order to be more efficient tomorrow with the new program aircraft. Next, please. We need also to prepare the future in the new environment for the aircraft. So we have, I will say now, UAV, UAM, drones, space planes, apps, high-altitude platforms. And so we need to deal with this new environment. So this is what I call the new entrance. Next one, please. So this is what it is anticipated tomorrow. I do not provide with the, I will say, main dates because I don't know when this will come, but will come definitely. So we have today where we are operating large aircraft, general aviation, helicopters, and very small drones. And so we are going towards what called the UTM, which is part of the future, and the new words will need to be integrated. So for sure, we will need to optimize all the new technology which will be put in place to, I will say, be able to manage those new entrants and new traffic. And maybe we'll take benefit from those new technology also on the air transport side. For sure, the transition phase will be key. And this one must be work very well in order to allow a smooth transition from one day to another world. Thank you. Next one. So what are the key messages regarding the spectrum aspect for aviation? So for sure, we still need protected spectrum for CNS in order to achieve safety and security objective. Traffic growth is coming back after the COVID-19 crisis, and we will have additional airspace users to manage. We need to take benefit from public markets and operators to deploy new proposed service on commercial aircraft for non-safety application. Here we have many opportunities which are coming. We need also to monitor the environment to anticipate congestion saturation aspect. Another point also, we need as aviation the 5G for our industrial, I will say, sprint. It is industrial 4.0, we need ramp up, but keep in mind that aircraft aviation has a longer cycle than the IMT cycle. So we need to be careful, and so we need really to discuss together to be well understood. So definitely our goal is to ensure the continuous safe operation of airplane in assessing and addressing potential interference between the 5G networks and the other ones, and aircraft system, while, and it is very important for us, allowing 5G deployment, including supporting the aviation industry, one potential risk and mitigating. So this is why really we need discussion of the two different words, because in fact we have common objective. Thank you. So I pass the floor to the next speaker.
Yeah, okay. Thank you very much, Claude. And so we've heard now from Richard on all the developments, well, some of the developments in telecom and how they see things, and we've seen all the spectrum needs in aviation. What is interesting to note, of course, is that people want to fly places safely. This is about mobility, and people want to use their mobile devices as well and enjoy all those services. So to me, both industries are really about mobility, but then they go to ITU and they all ask for spectrum or to maintain spectrum, etc. And so for that, we will now give the floor to Nikolai Vasiliev. He's the chief of the Terrestrial Services Department at the International Telecommunications Union. And so he will share with us a bit his views on how ITU works to arbitrate all these various demands for spectrum.
Thank you very much, Gary, and greetings to all colleagues. Do you see my presentation now?
Yes.
Yeah, I will focus on the international aspects of spectrum management.
It was good just before, but then you changed it again. Yeah, so we see just the slides in the normal PowerPoint. Now we see the preview. Yeah, we go through the cycle again.
Mhm.
Okay, now it's perfect.
Yeah, my apologies for this. Next time, I promise it will be fixed. So about international aspects of spectrum management, how it's distributed between different spectrum users to make everybody happy or unhappy, but equally unhappy. The spectrum is allocated at World Radio Communication Conferences. Normally, they take place every 3 to 4 years. One of the main objectives of this conference to accommodate newcomers, new applications, but with mandatory protection of the incumbent, the existing service. What is important that conference decisions, they're based, well based on technical arguments and technical grounds. So that means that before each WRC, the radio communication sector conducts almost 3-year studies of coexistence between new applications which require new spectrum and existing applications. And these studies results in the conditions or limitations imposed on new applications to protect the existing usage. These studies reported to the conference, which normally adopts these conditions. They go to radio regulations, and later on they are transferred in national legislation. To give you an idea about the scale of this event, the last conference 2019, it took 4 weeks, gathered around 3,000 participants from 163 countries. There was a lot of scientific and industry participants as well. One of the main concept of radio regulations is so-called block allocation of spectrum. It means that whole spectrum is divided into blocks, into parts, and each block goes to compatible service. Here you can see example. For example, this particular block is allocated to fixed satellite and mobile service, and they can operate normally without interference. The aviation spectrum is special case for many reasons. Firstly, because in many occasions it's exclusive. You can see in the green color the table which shows that, for example, for VHF band or for C-band aeronautical spectrum, you're alone in this block of spectrum. Nobody, no noisy neighbors and no roommates there. These allocations are normally also global. This is to provide interoperability worldwide basis. And these bands, sometimes they're quite large aeronautical bands, and sometimes they're located in quite attractive parts of the spectrum. And because of that, you're under the pressure sometimes from other spectrum users to take these bands for their usage. What is very important also that aeronautical spectrum is protected by several provisions in ITU Constitution and radio regulations because of safety of life usage of this spectrum. And on this table, you can see some examples of these provisions. Despite the aeronautical bands are quite protected in band, the recent years shows some problems of interference from neighboring bands, from adjacent bands. If we look back at the history of ITU conferences in the past, the majority of conference decisions were made without analyzing adjacent band interference. For example, if you see radio regulations, you will find no provisions for compatibility of sound broadcasting below 108 and aeronautical navigation above this band. Everything is settled by either by some ITU recommendations or by ICAO standards or by national management of stations there. The same example applies for L-band, where radio regs do not have any provisions for compatibility of IMT stations 5G below 1518 megahertz and terminals of mobile satellite above this band. And the same applies to radio altimeters in 2012 when allocation to IMT was made in the band 3.4, 3.6 gigahertz. Nobody can imagine that this identification of IMT may impact negatively radio altimeters, which was located almost 600 megahertz higher in this band. But this all the situation led to the change of approach by ITU, and at present time, almost all agenda items and all conferences, they look, before taking decision, they look both on in-band and adjacent band compatibility. And here I put a couple of examples for future conference, for mid-band 5G allocations or for hubs allocations below 2.7 gigahertz. One good example of this resolving the problem of adjacent band interference I would like to share with you, it's the protection of space sensors, which operate below 24 gigahertz and which can be interfered by 5G in millimeter bands above 24, 25 gigahertz band. The last conference, it established unwanted emission limits on 5G stations, meaning more strict requirements to filtering of transmissions to protect these sensors, which are very important for weather prediction and climate change. And this decision went to resolution of the conference, which has mandatory application, mandatory nature, and now it's implemented to 2 phases when more stringent limits apply after 2027, when we expect more 5G station deployed. This example can be kept in mind if similar situation happens with aeronautical bands to protect well before the conference decisions. The previous information was mainly about the classical spectrum management, which is now in ITU, so block, concept of allocation, condition for sharing, etc. But it's commonly understood that this classical approach may not be very efficient. So, and some unused or underused spectrum can be found for additional users, for additional applications. And several techniques and technologies came into place to try to unlock the access to this underused spectrum. And I listed several of them here, technologies like cognitive radio, which analyzes the signal situation before starting transmission. So geodatabases with stations, their frequencies, locations, frequency sensing devices, and several techniques like license shared access, dynamic access to spectrum, tiered access to spectrum. Everything is studied in ITU. Just to take one because of lack of time, for example, this dynamic access to spectrum, it means that additional users are authorized, but they're authorized on non-interference, not protection basis. It means no quality of service is ensured. They are obliged to stop transmissions if they create interference. This is quite heavy method because it requires database plus sensing techniques in case the database is outdated. And this, the example is white space devices in television bands in several countries. They were put in place. I'm showing this slide mainly to say that despite these techniques implemented in several countries, they're applicable to specific bands and for very specific conditions. So general applicability of these techniques for a long time is not yet proven. So it means that very cautious approach should be taken if somebody proposes studies of potential use of these techniques for safety of life services and safety of life bands like aeronautical bands. And in the end, I would like to just to move from technical aspects of spectrum management to some general aspects. And just to say that I talked to many aeronautical people from different organizations, and I have impression that there is a little bit lack of communication between, on one side of aeronautical community, like civil aviation authorities, and on the other side, national regulators and other stakeholders or spectrum users. So, and this can serve as obstacle to communicating your concerns, your spectrum requirements to others. And just to say that it's very important to communicate with all stakeholders at all levels, starting with national level, with telecom regulator, which finally prepares position to the conference or give license to others, licenses which can touch or impact your aeronautical usage. Also, it's very important to be present at regional meetings. There are now 6 regional organizations. You can see them here, and they really play an increasing role both in spectrum policies and conference preparations there. And of course, please come to ITU, to study groups, to conference, and ICAO makes a lot efforts, a lot documents, a lot policies for protecting and securing aviation spectrum. So finally, you may need to have friends in other industries to learn their needs, to understand them better, to inform about your problems, your concerns, your spectrum needs, and it may help to reach the compromise solutions between all spectrum users. Thank you, Gary. I think I finished.
Okay, excellent. Thank you so much for this interesting information, and for sure we're going to have to get more familiar with the various radio regulatory instruments that you talked about. It's funny too what you say about aviation needing to communicate, etc. It's a colleague of mine remarked that when we talk about 5G and radio altimeters, the telecom industry calls it the radio altimeter problem, and the aviation guys call it the 5G problem. So, but before we go more into that, and also I'd like to remark that really we're not going to talk about the details of the 5G versus radio altimeter debate, but really want to use this more as a trigger to discuss the greater issues. And so I'd like to come back to Claude's presentation. You showed a very interesting slide which would integrate multiple systems into systems that uses multi-band antenna. Well, in the past, of course, we've put these antennas so far apart to avoid interference between these individual systems. And of course, there are limitations on how much separation you can achieve on an individual aircraft. So maybe, Claude, if you can explain more what the key challenges and enablers are of achieving such system integration on the aircraft.
Okay, Gary, thank you for the question. Yes, obviously, this new kind of architecture will pose new challenges. Up to now, we were using, I will say, classical RF interfaces. And so we were using, for example, what we call suppression pulse for the L band. And so this was used in order to prevent one transmitting emitter from the other receiver in order to not blow it. Now, if we are using a software-defined radio, we'll be maybe able to drive it directly within and by software. We have another example where we have today on board 3 different VHF which can transmit and receive at the same time, because all 3 are fully independent. Maybe tomorrow, using this SDR, we'll be able to better manage and make repartition between voice and data according to the various duty cycle. So I think we have also in front of us challenges, but we are pretty confident that radio manufacturer and radio supplier will be able to solve them and then to optimize the way of working that we have today in order to solve this issue of, I will say, RF interoperability, but at aircraft level. Thank you.
Yeah, okay, appreciate that. So interesting challenges ahead. Nonetheless, it seems we are using a lot of systems that all seem to be doing the same thing as what Richard remarked, and this antenna level integration seems to be sort of propagating this further. We had a question from the audience, Sindre Hilstad from the Cockpit Association of Norway, European Cockpit Association, and AFALPA. He was noticing about how it's difficult for aviation sometimes to communicate its spectrum needs. And the question is, how can aviation, so agencies, manufacturers, professional organizations, help foster understanding for our safety critical needs? And I think this is where I'd like to turn to Richard, maybe to, explain to, okay, given how we are seen as you described, what ways are there in which we can build, more credibility, more openness for collaboration on the telecom side? Because funny enough, many in aviation say, well, the telecoms, they hate us, they don't want to talk to us, to put it bluntly. So how can this collaboration be better encouraged?
Thank you for the question. I think there's lessons can be learned from where similar, I don't want to call them confrontational meetings have taken place, but between other industries. So we have had very recently the example of broadcasters being squeezed in their UHF television spectrum to make way for mobile, and you would think that both sides would be unkeen, or at least one side would be keen on one thing and the other would be keen on something different, and yet they managed to work together. And I think it's about openness, it's about honesty, and it's about sharing information. And I think that's one thing sometimes that's difficult within what I've seen of the aeronautical industry, is that there is, if you like, an overload of information on what happens, but actually at the same time there is almost a closed door approach to some pieces of information, possibly because they are national in their nature, they're not international. So I might not be able to get the information I need from 3 countries, but I might be able to get it from 3 others, and that doesn't help me. I just generally feel there has to be far more of an openness. I'm not saying, and incidentally, I think there is a willingness already. I don't question the fact that there is a willingness between various parties to work together. But I think there is still a suspicious nature between the two sides. And I think a lot of that is just down to not having properly sat down and shared information to try and resolve some issues in the past.
Yeah, thank you, Richard. And actually another aspect is just what I observed from one of the past meetings is not speaking the same language. We all have our set of acronyms, and when people use that, it's sometimes difficult to understand each other. I'd like to take a question from the online questions, where somebody asks about your presentation, Richard, and maybe you can continue on that. Can you help us understand why efficiency is the most important metric rather than reliability and redundancy? And that maybe sort of plays on this idea that aviation sometimes may have that, well, you guys don't need to do reliable systems, we do. Well, that's probably not true, but on the other hand, yes, we need it to a greater degree. So maybe you can expand on that a bit.
Yeah, I think that as a spectrum using industry, given that it is a limited resource, we all have to work to use it as efficiently as possible. And I think reliability is a system issue, not a spectrum issue. You cannot have more, there is no more reliable spectrum than other spectrum. It's how you use that spectrum that generates the reliability. And it's also how you use it that generates the efficiency. So I think the two things are slightly different. We have a necessity to use the spectrum efficiently because it is such a limited resource, and yet fully understanding the need for the services that are using that spectrum to work reliably, effectively, have high availability. It's not just aeronautical that require that, incidentally. You could look at satellite communications. They also need a certain degree of protection because the signals are so weak by the time they've traveled 38,000 kilometers from the geostationary arc. So, that kind of reliability is built into other systems as well. But I think certainly from my perspective as somebody in the spectrum industry, my metric is efficiency, because if we're not using the spectrum efficiently, then we are wasting that resource.
Yeah. Thank you for that.
If I may add,
yes, please.
Gary. Yeah, I would agree completely with the statement that efficiency is very important for radio communication service, because finally we have this scarce resource. On the other hand, I have some sympathy with the question, because the purpose of, for example, mobile broadband networks and aeronautical radio navigation systems are completely different. Sometimes it's not possible to just apply this academic unit of efficiency, which is bit per second per hertz. It should be twisted a little bit, because if I may just go a little bit from aeronautical things, you say car, your car is efficient if it consumes less petrol per 100 kilometers. So, and if you consume 5 liters, it's more efficient than if you consume 8 liters. But you cannot compare this car with a firework car, which has completely different purpose. They safety of life car, and they are for different purposes. In this application, this economical criteria may not be 100% applied. So I would also, how to say, put in this equation also the safety of life aspects of aeronautical services, not just compare mathematically of efficiency of spectrum use. Thank you.
Yeah, okay. And I think we've covered with that also the question from Andrew Roy, who asked about how, bits per second per hertz applies well for communication systems, but not so well for navigation systems. And we've studied that in the past and seen those limitations. So really it needs more of a discussion maybe on how do we measure these things, how to prioritize access of these things. Okay, I'm coming to another interesting question, which is by Carol Brentek from the Military Aviation Academy. Can 5G technology be used in air navigation technology, in particular for landing approach paths? And so maybe Richard first say a little something about whether 5G standards are addressing this, and then Claude, how you see this, the role of that technology, and whether it's maybe something more for drones, or whether you think this could really be something also for civil aviation. So Richard, first to you.
Thank you. Just very, very briefly to pick up on the bits per second per hertz question. I know it's something we looked at, but if you take a navigation system and look at the accuracy of the data that you can get an equivalent value. And in fact, most navigation systems surprisingly perform very well on that basis. To come on to the 5G question, I think the thing here is that people talk about 5G as being the panacea. It will solve all communication problems, no matter what they are, because it's highly reliable, it has low latency, it has high bandwidth. That's all well and good. And I think the question is, could you use it to land an aircraft? And I think there's been a demonstration, hasn't there, in the past week or two of exactly that. But I don't think it wasn't the surveillance and navigation. It was the pilot who was replaced by a 5G connection, remote 5G connection. Can we use 5G as a replacement for many of the other technologies? Yes, I think we could. To me, and this has always been a question, it's the case of redundancy and performance, because if we rely on a single system to deliver communication and navigation and potentially surveillance, that system becomes absolutely critical. And we've already talked about the need for protecting safety of life. And I'm not sure that even passengers would be happy thinking that their aircraft was landing on the same system that they were checking their Facebook on. Gary, back to you.
Yeah, okay, so over to Claude.
Okay, so just to complement, so I will answer a little bit differently. If we take example like Aeromax was derived from WiMAX standards. Then we have also in study LDAX, which is also derived from existing telecom standards. So from aeronautical point of view, we are using, I will say, the new technology. But then from a pure spectrum point of view, I fully agree with Richard. we need to perform demonstration regarding performances, assess safety, redundancy, how can you ensure priority. And so if at the end the 5G allocation become a safety of life, why have a safety of life itself? So we can for sure maybe imagine to use 5G as a complement in order to try to have additional redundancy. Maybe UAV or small drones will open this aspect. But again, I'm still very cautious regarding the performance and the demonstration, because maybe you will be able to use private networks in order to ensure that at airport areas. But again, it will be a long path. So, okay, thank you.
Yeah, thanks for that. There's a follow-on to that, maybe a bit more detailed on what you were just explaining, Claude, from William Cecil, Flith Aerospace Solutions. What are the views on the value of 5G for future airport surface data communications for AOC, AAC, and for ATC compared to current, prior, or planned use of WiMAX, Aeromax, 4G LTE, 3G, and 802.11 Wi-Fi gate link services? If you can maybe continue on that a little, Claude.
Yeah, no problem, we do. So for sure, ATC is still using safety of life frequency spectrum, okay? For some AOC and ATC airlines are already today using Wi-Fi, 4G, LTE, and maybe in some cases 5G.
I think, sorry
and this
to interrupt.
particularly when the aircraft is on ground.
We may need to say what AOC is. Maybe not everybody knows that.
Oh, sorry for acronyms. Okay, we are every day inside. Okay, so AOC is Airlines Operational Communication. AEC is Airline Administrative Communication. ATC is Air Traffic Communication. So AOC, it's also unfortunately displayed in two parts. One of AOC are considered as ATC, so safety of life. The rest is not considered as safety of life, but just pure operational. And for those ones, we are using, as I mentioned, Wi-Fi, 5G, some cases, 4G and LTE. When the aircraft is on ground, for sure. Regarding Aeromax, we have all the standards in place from aircraft point of view, so everything is ready. Unfortunately, it's not still deployed. Some few airports have, I would say, using the Aeromax technology, but not yet on board aircraft. So here there is a kind of competition, typically with telecom operator, putting in place networks at airport area, which provide, I will say, the same kind of services. So for sure, if we want to ensure safety services, you are not able to use this kind of services. And so Aeromax will be the best one because it is by nature protected from spectrum point of view. But again, here we are, I will say, in the competitive environment, and maybe some airlines and airports prefer to use those, I will say, telecom operator network rather than the Aeromax one. Thank you.
Yeah, thank you. So indeed, it's quite a lot of technical detail that goes into this and deciding what parts of 5G can be used for what. There is one question that I hear a lot, and that also a lot of people in the audience ask. Multiple people have asked this, and I'd like to turn to you, Nikolai, for this, which are wondering why 5G is a problem in the US and not in Europe. Not sure we can really say it's not a problem in Europe, but of course, as you said, there are sharing studies that need to take place. Power is a key issue. So maybe you can comment a little bit what your views and perceptions are of why something might work better in one region of ITU versus another region of ITU.
Thank you. I think, Gary, there are two factors which may explain this difference. Firstly, as far as I know, the power of 5G applications used in US is higher than the power of applications used in Europe. And the more power you have, the more interference may happen. But these interference are not, how to say, proven in reality, experienced by aircrafts, but they, how say, calculated, and they proven by testing of some equipment. And the second factor which plays, it's the proximity of the bands used in US to the band of radio altimeters. So I think they go up to 3,980 megahertz. So it's quite close to radio altimeters bands, while Europe has CPT decision to stop the 5G at 3.8 gigahertz. Thank you.
Yeah, thank you.
Okay, if I may, I would like just to add one topic, Gary, if possible. Okay.
Please, yeah.
Just one aspect is also we need to okay, thank you. One aspect is also to consider what we call the antenna scan angle from the base station, because in most of Europe we have a limitation in the scan angle, and the scan angle from the base station is limited to the horizon. While today in US, if you are looking for the FCC report and order, you can radiate at the vertical of the base station, and which is key in order to, I will say, affect radio altimeter which are in a landing approach. Thank you.
Yeah, okay. Yeah, so it's a very interesting issue. Maybe to stay with Nikolai, also a lot of airports have approached us and asked us, what is it that they need to do to ensure that radio altimeters work interference-free at the airport. Maybe you can explain a bit more about the different responsibilities of the various actors between airport authorities, national regulators, and aviation.
I would pass this question to Claude, Gary. I think he is more involved in this, airport issues. We manage spectrum more at the level of national telecom regulator or policymaker. We don't go, not much information about management in the airport, but they should know about the problem.
Yeah, and indeed that was kind of my intended point. Sorry to put you on the spot like this, but really the interface with IT was by the national telecom ministries. So maybe Claude, you can share with us your expectations as an aircraft manufacturer on what airports should be doing to make sure radio altimeter operations are safe.
Yeah, the difficulty is that here we need to speak to both the telecom operators, which is on the country with the, I will say, administration, and the civil aviation also. But from pure airport aspect, airport today need to apply what is the ICAO Annex 14, and also the part of the FAR 77, which is applicable for surfaces. This means that you need to respect some rules in order to implement, I will say, buildings or station or antenna or whatever, in order to be aware of what it is authorized or not in terms of, I will say, physical implementation. Then once this has been said, you need also to, for the airport of the given country, to be aware of this potential phenomenon of interference between the 5G and radio altimeter. For sure, as already explained, frequency band is important, radiated power is important, scan angle of the base station is important, and all those factors need to be considered by the telecom operator when implementing base station around the airport itself. Because we can have also some, I will say, go around aspect on a given airport, and then you need to trigger the question, what happened? In order to cope with that, we need to have discussion with civil aviation and the telecom administration. We are on the, I will say, aviation side, launching new radio altimeter standards, which will be more robust to this new 5G environment. Because as you know, on most of the radio systems on board aircraft, we have standards which are, I will say, made, I will say, 30 years ago. And so the RF environment was not the same at that time. So now we have to define new standards, new altimeter, and pending those new developments, which will be in place in order to offer more robustness on aircraft system, we need to get some mitigation at airport level. By mitigation, I mean maybe to reduce a little bit the power, to reduce the scan angle in order to still offer 5G services around the airport, but not impacting too much the aircraft operation. So this is the way we need to work. Unfortunately, it will be a transition period, but we need it because everyone needs 5G, but everyone needs also to land safety. Thank you.
Yeah, thank you for that. And tied on to that is also maybe a bit of a hypothetical question, but still one that is interesting from a hindsight perspective, from Felix Butch from DFS, the German air navigation service provider. And he's asking whether aviation would have really engaged into upgrading the radio altimeter standards if it were not for the introduction of 5G in the adjacent band. And this maybe plays also on, what are the triggers really to advance the technology? If you can continue on that a bit, Claude, please.
I will continue on that if you want. Yes, I will continue on that. Okay, yes. So for sure, since I will say 1 year and a half, we started the investigation in order to see what we can do. So among the famous RTCA report about, I will say, the potential susceptibility of radio altimeter to 5G, we launched also the activity to define a new MOPS. It is minimum operational performance for radio altimeter. The idea is to create, I will say, a new standard which will define the new performances which are foreseen for new radio altimeter in order to be, I will say, robust to the new 5G or 6G, I don't know, environment. So we expect to have this new performance standard mid-23, I think the best option, and then to be able to launch a new development for new radio altimeter, which will be, I will say, robust to this new RF environment. So today, this is a goal. You need to know also that from a joint EUROCAE RTCA working group, a new group has been created in order to tackle with spectrum aspect on all CNS systems. So the idea is also here to address this, I will say, 5G issue and to have a look on other systems on radio navigation, communication, and surveillance in order to assess which system can be also affected in the coming years by such, I will say, similar environment, and then make an update also associated for the performance of those systems in order to also run them more robust to this new environment. So things are moving. I hope that we are in the good trend, but this will take time. Unfortunately, we are in aviation. You know that aviation cycles are more longer than telecom operator cycles, but we need to hurry a little bit. Thank you.
Yeah, thanks for that. So, and my apologies really for all those that are asking a lot of questions about 5G and radio altimeters. We also did not really put the panel together in this way. There are people that are more active in this debate, so it's really about the larger issues. And on that, I want to ask Richard now. You've mentioned a bit the desirable frequencies and how a lot has been allocated at very high frequencies. In general, the sweet range of frequency seems to be between 500 megahertz and 6 gigahertz. And now it seems that aviation shouldn't have been surprised, but has been surprised about this development around 4 gigahertz. Maybe you can say a bit more about what telecom priorities are for the next couple of years, especially when there are priorities that are near aviation frequency bands.
Yeah, I mean, the notion of a sweet spot is based on the idea that you get the right balance between being able to provide coverage. So you need a lower frequency and capacity, which generally means more spectrum and is at a higher frequency. And I think, 20 years ago, the sweet spot would have been around 1 gigahertz, but that's changed due to the demand for capacity and has moved that sweet spot up. And I think you're right, Gary, something between 500 megahertz and 6 gigahertz is right. There's a couple of things we need to bear in mind. There is a second 5G band, which sits exactly on the opposite side of the radio altimeter band to the one that the discussions are going on in the US about, starting at 4.5 gigahertz. And you asked about priorities for the future. I can see that band becoming more interesting as it slowly opens up. It's common in Asia. Japan, China, and others are using it. It was identified by a number of other countries at the last WRC, and I think we can potentially see more countries adding themselves to the footnote to enable that. So there's something to keep an eye on. But generally, there's also another agenda item to look at spectrum around 6 gigahertz for IMT. It's fundamentally the piece of spectrum used for uplinking to satellites, and whether or not that could be used. And as much as there is mountains now of millimeter wave spectrum that can be used for mobile, there is still, I think, a demand for spectrum that can provide that right balance of capacity and coverage. And some of the aeronautical spectrum definitely sits within that sweet spot.
Okay, thank you. Another question that is, Richard stated maybe more about the needs of where the priorities are. Then the next challenge is really, how does aviation evolve? Jasper from VNV writes that part of the reasons for the slow introduction of new technology in aviation that it's global. All parties have to join, and there's not very much investment. And so we kind of are driven by the slowest partner. Are there ways in which we can encourage development that would start first by region somehow in Europe or North America? Or, you know, how do we drive aviation forward in a way? And how can progress be made? And I guess either Nikolai or Claude, if you could address that. Do we have any takers?
Maybe I can start, and Nicolas.
Yeah.
Yeah, I will start, and then Nicolas will complement. Okay. The difficulty for aviation is that we are working worldwide, and so we need to be interoperable everywhere. So we cannot imagine to change one system to another one, going from US to Europe. Okay, so this is a difficulty for, I will say, evolving in air transport, and this is why we are following ICAO rules and guidelines. We can also imagine to be, we'll say a little bit more quick in developing our standards and take benefits of the new technology. Unfortunately, I take this example of MLS. We talk, I will say, 15 years to develop MLS, and at the end, when MLS was developed, no usage because no business, and so no interest. So we need to be really careful with this, I will say, timing aspect. Oh, sorry, again, thank you, Gary. Okay, so we need really to be careful taking so long time to develop system, which at the end are, I will say, arriving too late in order to be, I will say, interesting for air transport and competing with other things. So for sure, we can develop some regional solution, but again, we need to keep in mind this global aspect of interoperability at air transport level, because one aircraft operating during, I don't know, 1 or 2 years in one airline in US can be sold again and to be operated in Africa. So this is something, and so the intent is to not change every time you change countries, the aircraft with the system. Keep in mind that the duration life of an aircraft is almost between 30 and 35 years. So you can understand that modifying aircraft is a complex aspect. And so you need also to cope with the ground network, which were deployed by the various administration and country and civil aviation. And so it's not an easy task, but I can understand the question. Thank you.
Yeah. Okay. Anything to add to this one, Nikolai?
Yeah, I would just like to invite people to read your very good think paper, where this problem, I think, raised and well answered. So aviation has some natural obstacles to fast replacement or modernizing its equipment, including what Claude and I would add said, and I would add also financial issues there. For example, we have the recent paper of frequency spectrum management panel, which says that in accordance with one large aircraft manufacturer, it has 15,000 planes in operations, all equipped by radio altimeters, and only the latest generation of these altimeters can be robust enough to be protected from interference from 5G. So it means that 10,000 aircrafts may need to be replaced or refitted with new radio altimeters. It would cost several billion of dollars in estimation of this manufacturer. So there are some objective reasons for this slow path, but certainly aviation should take some efforts to do it.
Yeah. Okay. Thank you
Gary,
for that.
if I may just have 30 seconds. I think
Yes.
there's one thing that's being missed here. We're talking about ground stations that provide a service to aircraft. The aircraft take 35 years to be replaced, which means the ground stations can't be updated until the aircraft are updated. There's a catch-22, but that doesn't apply to standalone systems that don't interact with any ground infrastructure, which would be radio altimeters. And it wouldn't apply to introduce something new that's not replacing or modifying something that already exists. I just thought, I'd throw that in.
Good point. Okay, good. So with that, unfortunately, already it is time for us to wrap up. We could for sure easily continue these discussions, and I'm sure many of these more discussions will take place between various people. So thanks a lot for all my panelists for this discussions on how to move aviation spectrum forward in conjunction with 5G and in collaboration with the telecom industry. So I'd like to just give everyone some opportunity for some closing words. And I start with you, Richard, if you can just offer us your closing thoughts.
I think for me, the fact that this seminar is taking place and that there is a recognition of the need, firstly, for looking at spectrum efficiency and monitoring it, and also to open up that dialogue between aeronautical spectrum users and other spectrum users, I think is the right way to go. So I think you're doing the right thing, taking the right steps. Maybe it's time to put the running shoes on, though, and move just a little bit quicker.
Yeah, okay. And funny enough, it's not for lack of, people like us that are CNS engineers for trying. We'd very much like to put new systems on aircraft. So over to you, Nikolai, for some closing words.
I would just like to say again, to remind people that aviation is very important, but it's not the only spectrum user. There are others not less important for population, for governments, and some of these telecom technologies grow very fast. They naturally require more bands, and they're looking sometimes at aeronautical bands as well to accommodate their services. So it's crucial to cooperate with everybody and stay vigilant and to predict the risks for aviation spectrum and make some solutions, especially in preparation to World Radio Communication Conference, when decisions are made to give one or another spectrum block to other users.
Thank you so much, Nikolai. And over to you, Claude, for the wrap up.
Okay, thank you, Gary. So maybe for me, this will say the word maybe a little bit strong. This 5G crisis versus radio altimeter allow to trigger a lot of initiative on the aeronautical sector. So a lot of action have been taken on ICAO side, on ARTCA, EUROCONTROL side, and I'm pretty sure that the aviation will, I will say, move a little bit faster in order to better understand and to better manage this kind of aspect of interferences. For me, we need to coexist. There is no one sector against the other. We need to have our, I will say, our own needs. We need to work together, to understand together. And so we need to explain what it is safety for us with associated, we'll say, technical answers. So hope that we'll be able to cooperate in the coming months, years, in order to better live together. Thank you.
Yeah, so thank you so much for all these good contributions. My apologies for all the questions that we were not able to answer. there's still a very good indication for us to see what people are asking about. So maybe we'll have chance to pick some of these up later opportunities, which is also my advertisement for future EUROCONTROL Stakeholder Forum webinars, which will be advertised through the same kinds of channels. And also we will have a think paper that will come out about this whole issue that we have just discussed today, about making better use or best use of this scarce resource in light of the 5G debate. That will give some more thoughts around on this topic. And so I invite you to read that as soon as that comes out, which should be in the next couple of days. So with that, we thank you for tuning in. We thank you for your thoughts and your attention to this topic. And as everybody has said on this panel, let's hope we can take this cooperation further so that 5G and air transport are supporting mobility of society in the future in the best possible way. Thank you so much.